Hello everyone. CONSTEKNOSforum welcomes all you construction technocrats. Today we will discuss about a software developed on Excel with Visual Basic. It is developed to make concrete mix design easier for material and field engineers. So, what is concrete mix design? Concrete is a composite material made up of cement, sand and aggregate. Concrete mix design is the process of determining the proper proportions of various elements to obtain the desired strength. Concrete building is most cost effective when the concrete mix design is done correctly. Big structures such as bridges and dams necessitate a large volume of concrete. However, employing the proper amount of elements make the structure economical. Concrete is a heterogeneous and hardened material made from a certain proportions of cement, fine aggregate, coarse aggregate and water. Concrete mix design is the process of determining the proportions of the various components that need to be combined to create a concrete mix with the desired properties. The mix design takes into consideration factors such as the strength, durability, workability, and desired appearance of the concrete, as well as the specific material being used. The goal is to create a concrete mix that is cost effective, easy to place and compact, and that meets the performance requirements for the intended use. Concrete mix design is a crucial process that involves several steps, calculations and laboratory testing to determine the optimal proportions of ingredients required for a concrete mix to achieve its desired strength and durability. The mix consists of 5 primary components: cement, water, coarse aggregate, fine aggregate and air, which are combined in various proportions. The proportions of these components must be determined precisely to ensure that the concrete achieves its maximum strength. Essentially, mix design involves selecting the appropriate material and quantities to create a concrete mix that meets the desired specification for strength and durability. The process of determining the proportions of the various components to create a concrete mix with the desired properties are complex in nature and require a lot of effort on the part of experts in the field. So, here I am presenting a software developed on Excel with Visual Basic to make the concrete mix design easy and simple. And most importantly, it is very easy to operate. Even a beginner level of Excel user can operate it. And of course, it is almost free. So, let us see how this software works and how to operate it. The very first sheet is the title sheet, where the direct link to this video is given so that whenever you need guidance on using the software, you can connect to the video. The second sheet is for blending of aggregate, which is the first activity before proceeding to mix design. Here we have to record the percentage passing obtained from the sieve analysis of coarse aggregate as well as fine aggregate. This software is designed to blend up to 3 different sizes of coarse aggregates. First, you need to select the size of all 3 fractions from the drop down list here. If you only have 2 fractions, select dash for the third fraction, and if you only have 1 fraction, select dash for the second fractions as well. Here we will consider 2 fractions, one of 20 mm and the other of 10 mm. So select dash dash for the third one. Now click on the icon here to feed the data. Please enter the percent passing of fraction 1 and 2 for sieve size 80 mm separated by a space. This means that the percentage passing the 80 mm sieve size for both fractions is to be recorded with a blank space between the two. Similarly, enter the percentage passing for all the sieve sizes. Now, to blend these two set of inputs to get the desired gradation as per IS 383, simply click on the chart for auto blending. This way, the computer provides you the best possible combination of these two sets of aggregates. Here you can see how close your blending is to the middle range of the boundaries. It is 98.08%. If you are satisfied with the combination, then it is okay. Otherwise, you can change the combination by clicking Ctrl Shift B or Ctrl Shift N key combination. This is a representation of table 7 of IS 383. Green colored cells indicates that our blending satisfies this limitation. If you want to verify the gradation of a single size aggregate, then you deselect all fractions other than the fractions whose gradation you want to verify and simply click on the chart. These green colored cells indicates that the selected aggregate satisfied this limitation. Now, let us come to the next point, the selection of fine aggregate. I have already fed the data for the fine aggregate which was available with me. As explained above, for coarse aggregate, click on the chart for automatic blending. Here you have 4 options. Type 0 to blend all 3 components, 12 to blend component 1 and 2, 13 to blend the component 1 and 3, and 23 to blend the component 2 and 3. I am typing 0 here to blend all the 3 components. Look at this color band above the chart. Here 3 by 6 is written for zone 1, 6 by 6 for zone 2 and 5 by 6 for zone 3. It indicates out of the 6 sieve sizes of sand, how many sieve sizes of the particular zone are satisfied. Hence, the sand belongs to zone 2 and is 93.19% close to the middle of the limits. If you are satisfied with this combination, then it is okay. Otherwise, as explained before, for coarse aggregate, you can change the combination by clicking Ctrl Shift B or Ctrl Shift N key combination. One thing to note here is that if our combined grading does not satisfy any of the 3 zones, you will see 3 options displayed on the right side of the chart. You can select the zone that best suits you from here. Or you can directly choose the best possible option by clicking on the best fit icon. Now let us come to verify the gradations for the all-in aggregate case. Here you can see a guidance written in pink. After finalizing the mix design, the percentage of coarse aggregate shall be taken from Article 8 of the mix design, that is, determination of coarse and fine aggregate. The percentage of coarse aggregate depends upon many factors, hence it is better to re-verify the proportions after finalizing the mix design. Now let us come to the main sheet of mix design. Enter the data and mix design number here. This light blue strip indicates the input points where data input is required for the mix design. Provide input in the gray cells. Now we select the water cement ratio with the help of the chart given in IS 10262, which depends on the grade of cement. To do this, you simply need to click on the chart and the computer will automatically select the ratio for you. If you notice a slight mismatch on the chart, you can fix it by changing the value of this cell to exactly match the chart. From the chart, the water cement ratio comes to be 0.35 and as per specification, it can be maximum 0.45. So, we are adopting 0.35 here. In case of pumpable concrete, you can reduce the volume of coarse aggregate by a maximum of 10%. As mentioned earlier in the previous sheet, after finalizing the quantity of coarse and fine aggregate, the percentage of coarse aggregate here to be re-verify for all in aggregate. So just click on this icon, re-verify percentage of coarse aggregate for all in aggregate, and come back to the mix design sheet. Now your mix ratio is ready for SSD condition. Here is the adjustment for wet aggregate. Here is a summary of the mixing proportions for all three conditions. Here you have to select the number of cubes required for the trial mix. According to Morth, it is 9, but you can select more if necessary. The next two sheets are self-explanatory. That's all today. If you need the Excel file of this software, see the description. See you soon with a new topic. Till then, goodbye. Jai Hind, Jai Bharat.